We want to differentiate this function and also find out where the tangent is horizontal by solving the equation dy dx, or let's just say y dash, equal to 0. So we have to use the chain rule to solve this. So let's just set u equal to x minus 5, which means u dash is just going to be 1. So we've got y equals u to the power 4, which means y dash is going to be 4 u to the power 3 times u dash, which is 4 x minus 5 to the power of 3 times 1, which is, simplifying it, 4x minus 5 to the power 3. Now, to find the coordinates where the tangent is 0, we have to set this derivative to 0. So, solving this, dividing both sides by 0, we have x minus 5 power of 3 equals 0. Taking the cube root, we get x minus 5 equals 0, which means x is 5. Now, we can sub back into our original equation to find that y is going to be equal to 5 minus 5 to the power of 4, which is equal to 0. So, the coordinates where the tangent is 0 is going to be 5, 0. And this kind of makes sense because this is like the equation y equals x to the 4, except it's been shifted right 5 units. Now, if you remember when we were doing parabolas, y to the power of 4 is just going to be like a squarish parabola going through the origin, which means this one is going to be like here, just shifted right 5 units. And we can see that the place where the tangent is horizontal is at the base of it, which is at 5, 0. So we see that it works. So let's try another problem. Here we've got 1 over 1 plus x squared, and the first problem is we hate fractions. We need to turn this into some sort of power. So let's rewrite this as y equals 1 plus x squared to the power of minus 1. Okay, now we have u is 1 plus x squared, which means u dash equals 2x. So y, which is u to the minus 1, means y dash is going to be minus 1 u to the minus 2 times u dash, using the chain rule. Now that's going to be minus 1 plus x squared to the power of minus 2 times 2x. And if we rearrange this, we get minus 2x over 1 plus x squared all squared. Now, we want to find out where the tangent is horizontal, so we set the derivative to 0. Now, notice that the bottom can never be 0 because it's always going to be positive, and always going to be greater than 0 because of this x squared is always positive, so this whole thing is going to be greater than 1. So we can multiply both sides of this equation by 1 plus x squared squared, and we're just left with minus 2x is still equal to 0, so we've got x equals 0. That's our x coordinate. We then sub that back into our original equation, so we get y is equal to 1 over 1 plus 0 squared, which is just y equals 1. So the coordinates of our point is 0, 1. And that solves our problem.